those were the acid-base reactions. We also mentioned the gas evolution reactions. Here we've got two aqueous solutions that mix together and they form a gaseous product, which will bubble out of the solutions. So sometimes this happens directly from the ion exchange. Here at potassium and sulfur, and reacting with sulfuric acid, we get potassium sulfate and H2S. This is a gas. And so that's just going to form the gas that bubbles out. Other reactions are going to form the gas because one of the ion exchange products is going to decompose. It's unstable. So an example of this is sodium hydrogen carbonate, which is baking soda, reacting with hydrochloric acid. If we swap the partners and predict what we're going to get, we're going to end up with sodium chloride and H2CO3, which is carbonic acid. Carbonic acid, as an aqueous solution, is not stable. It decomposes. It decomposes to form water and CO2, and those are the bubbles that we see in soda and other carbonated beverages, is carbonic acid decomposing. And decomposing isn't necessarily a bad thing. It doesn't mean it's rotting or anything. It's just, it's coming apart. Like, it's uncomposing. Like Bach in his grave, he's decomposing. So when you when you mix a baking soda solution with an acid solution, you're going to see fizzing. That's the CO2 gas that's formed. So these are the intermediate products that you are responsible for knowing for this class. So one of the examples is if you get H2S as one of the products. We're just supposed to know that that's a gas. That's actually a very, very smelly gas. It smells like rotten eggs. Hydrogen sulfide, yep. Doesn't smell good at all. There's lots of very smelly sulfur compounds. And they use those like natural gas. You know, if like we turn on one of the gas jets, people are going to say, wait a minute, I smell gas. Natural gas itself has no smell, which would be really dangerous because the gas jet could be on and you wouldn't know until someone sparked something and then the whole building goes kablooey, right? Really, really bad. So to protect everybody, they add a little bit of a sulfur compound to the gas that is so strong smelling that it just takes a little teeny tiny bit and your nose can tell. So that's why liquid propane, you get the gas in the can for your gas grill, and it smells bad. Right? They made it smell bad to protect you. Sulfur compounds do not smell good. Anyway, so for these gas evolution reactions, we're going to approach them the same way. We're going to look at the ions that are coming in. We're going to swap the partners and see what we get. If we get H2S, we have to say that's a gas. If we get H2CO3 or H2SO3 or NH4OH, we have to recognize those are unstable. They're going to form a gas. So there's 4 things you have to memorize, right? And again, the ideas of like the titration calculations, solution stoichiometry, writing balanced chemical equations, those things are super, super important. Remembering these unstable compounds that form gases, not as important, okay? But you need to know about it. Yeah, pick your battles. You can't do everything, right? You just can't. Nobody can. And so you have to pick the most important things. Remembering these is not the most important thing. So how do we remember what gases these formed when they decompose? Okay, that one actually, I've got something, it makes sense to me anyway. So H2CO3. When these things, all 3 of them, when they decompose, they're going to give us a water molecule, and then the other pieces are going to be the gas. So when this decomposes, I'm going to get H2O. So there goes those two H's, and there goes one of the oxygens. So what do I have left? I have CO2. If I have H2SO3, that's one of those that decomposes, it forms H2O. So I'm going to lose those two H's and one of the oxygens. I'm going to get SO2. There's that. NH4OH decomposes, forms H2O, and let's see, I'm running out of colors. Let's try black. So I'm going to get rid of this hydrogen and one of those hydrogens. I'm going to get rid of this oxygen. Because there's two hydrogens and an oxygen that I take out of this. That makes the water molecule, and everything that's left is NH3, which is this guy. Okay? Write a molecular equation for the gas evolution reaction that occurs when you mix aqueous hydrobromic acid and aqueous potassium sulfite. This question says there's going to be a gas evolution reaction, right? So then we should be on alert. Well, we have to write the formulas for the reactants. Hydrobromic acid. Hydro at the beginning tells me it's not an oxyacid. It's just hydrogen and bromine. So hydrogen is H+, and the bromine forms the ion Br-, so that's going to be HBr. And aqueous potassium sulfite. Well, potassium is K+. Sulfite is the light version of sulfate. Sulfate is SO4. Sulfite is SO3. They both have a 2- charge. So this is going to be K2SO3, and that's aqueous. So that part is just nomenclature, writing formulas from names. Now we're going to swap partners. And so I'm going to write the new possible combinations here, K+, and Br-, H+, and SO3, where that came from, 2-. So this is going to be KBr, that's going to be aqueous. And here, I'm going to need 2 hydrogens to balance the charge on that, so I'm going to end up with H2SO3. That's an acid, right? That's aqueous. And then we need to balance it. Thankfully, there aren't hydrogens everywhere here. So I have 1 hydrogen here, and I have 2 over there. So I'm going to put a 2 in front of the HBr. I've got 2 bromines, and over here I have 1. So I'm going to need to put a 2 in there. And then I've got 2 potassiums, and 2 potassiums, and 1 sulfite, and 1 sulfite. We're not quite done. This is a gas evolution reaction. Well, KBr is not going to form a gas, but this guy is. So what's going to happen is this is going to decompose and form water, and get rid of those 2 H's, get rid of one of the O's. SO2 is the gas. Also very stinky. HBr is K2SO3, 2KBr, plus what that H2SO3 decomposes into, H2O liquid and SO2 gas. That's a good question. So if this is aqueous, does that mean there's no reaction? No, because this doesn't stay like that. It decomposes into H2O and SO2. And so now we do have two new things that are formed. If we did a net ionic equation on this, and we weren't super careful because this is a weak acid, we could end up crossing off all of our ions and having nothing left. But that's a good question. But because it decomposes and forms a gas and a liquid, then there is a chemical reaction. Any other questions?